Good evening and welcome to what should be video number 2, but is video number 1 of Mr. Smith's AP Stats online notes. I think we've gotten the bugs ironed out here, and so we're ready to rock and roll for our video tonight. So looking again at Chapter 4, Designing Our Studies, we've talked about some sampling methods, how to sample poorly, and then the way that we want to go about sampling. And so tonight we'll take a look at a couple of different types of sampling, random sampling methods, because a simple random sample isn't always the easiest thing to carry out. So we talked already about the basic idea of sampling is pretty straightforward. We're taking SRS from the population, use your sample results to get information about the population. Sometimes there's some advantages to using a little bit more complex sampling method. With an SRS, we talked about every combination for your sample is equally likely. So going back to the football stadium and Taco Bell deal, if we want to replace this football stadium with a Taco Bell, if we're going to, even on the Friday night of the Franklin Central Roncalli game, we still want to use that group. We could, and we could do a simple random sample, right? Because we know that Roncalli fans might think differently than Franklin Central fans. We think students might think differently than adults. And even young adults might think differently than older adults. The football players might think differently than the rest of the population. If we take a simple random sample, then it is entirely possible that our entire sample will consist of Roncalli fans, at which point they're going to say, sure, blow up the stadium. We don't care. It's not our stadium, right? Or it's entirely possible that our entire sample comes from the student population, which, I don't know, you guys would rather have a Taco Bell. I don't know. There may be some systematic, there may be some reason for students to provide a similar answer systematically. So on top of which, if there's 4,000 people in the stadium and I want to take a sample of 200 or 300, an SRS requires me to go and find each individual and survey them, and that could take a while. So one alternate way to create a sample and still be a random sample is something called a stratified random sample. What we can do is we can divide up the population into what we call strata. Doing that, the subsamples or the strata become those groups that we feel might answer the same, right? So we'll group Roncalli fans. We'll group Roncalli versus FC, and then we'll group students in one part, and young adults in another part, and older adults in another part, and then we'll have the football players, right? So we'll create, those are your different strata. Each group will probably provide a similar answer for whatever reason, because they tend to think sort of the same, right? Those are going to be our strata. So when we do that, to get a stratified random sample, we're going to classify those groups first. And then we'll choose a separate SRS in each strata, right? So maybe I divide up my population into 4 groups, each group with similar thinkings or similar characteristics. And then if I want 100 people or 100 individuals as my sample, I'll go and grab 25 from each group, okay? And that will form, those different subsamples combined will form our entire sample for our survey. So we'll divide everybody up into equal characteristics and then take a few from each still in a random manner, and that will become our random sample, to become our stratified random sample. So strata need to be groups that are similar in some way. Okay? So that's one way we could do it. Now, we get a little bit of an issue with even the stratified random sample. So we've taken out the possibility of getting our entire sample coming from one group. So all of our samples not going to come from Roncalli now. All of our samples not going to come from the student section now, right? We have set this up so that I get a few from each group, and so I get a good mix of those opinions, okay? And should get a better idea of the population as a whole, all right? Other than the fact that we're still at a football game, but that's beside the point. Bear with me for a second. Now, the issue with a stratified random sample, now that we've taken care of this, we may get all of the same opinion, we still have to go find the individuals, okay? And that's going to be hard in the football stadium to go find, the one individual that you need to talk to in each group, or the 25 individuals you need to talk to in each group. So there is another method that will help us take care of that problem, right? Both an SRS and a stratified random sample suffer from this sort of, it's difficult to carry out kind of a problem. So there's another method in that will help us with that. We would maybe, if that's going to become an issue for us, we might prefer to use a method that selects groups of individuals that are near one another, right? And so to do that, what we're talking about is taking a cluster sample. So we're first going to divide the population into smaller groups, right? It's just like we did with our strata. We're going to create smaller groups. Only now, instead of making them groups that have similar characteristics, we want the smaller groups to mirror the population. We want it to be a good mix in each group. So we no longer have a student section in the we sort of make it to where all of the fans are at the football game are mixed in together. Roncalli's not on one side and FC's not on the other side. Everybody's sitting together. There's not a student section. All the students sit by their parents and their grandparents, right? All of the fans are mixed in together. But we're going to, so if that's the situation, then we're going to separate that group into different sections of the stadium, right? I don't know how it's section 101 or 102 or 103 or section 1, 2, 3, 4, 5. But we're going to break them up into smaller groups as long as those groups are sort of mixed in together, right? Those are going to be our clusters, right? So our clusters need to mirror the characteristics of the population. Then we're going to choose an SRS of the entire cluster, okay? It's going to need to be of the entire cluster. So instead of taking individuals, we'll take the entire cluster. So it's going to be, we're going to choose an SRS of the clusters, and we want to take the whole cluster. Oops. Okay. So if we need, if we break up our groups into sections in the stadium so that there's 25 people in each section and we need 100 individuals, then now what we'll do is we'll label the groups, not the individuals, we'll label the groups and then choose to, either using table D, the table of random digits, or some other random device, we'll randomly choose 4 of those groups, 4 of those 25 groups, and that will become our sample of 100, right? So that would be a little bit easier to carry out, right? Now I know where to go to get my 25 people. All of my 25 people are in one location. I can go to that one location, talk to those 25 people, and move on to the next location. Okay, so the difference here between strata and clusters, we're still breaking the population up into groups, But for strata, we want the groups to be the same within the group because they have some similar characteristic. I'm going to grab a few from each group so I have a good mix of opinions. With clusters, we're going to break up the population into smaller sections, into smaller groups, but we want the groups to mirror the population. So we want the groups to be mixed up already, and then we can just take the entire cluster, okay? The only issue with clusters is sometimes it's tough to get that mix, to break up the population into those smaller groups into a mix. But there are three methods here in SRS, a stratified random sample and a cluster sample, that have their own sort of advantages and disadvantages to each of them. Okay, so those are some alternate sampling methods. Okay, now let's take a look at this example that is on page, let me find it real quick, 219, on page 219. And a little bit different situation, get away from the football example, which may not have been the best example to take a look at anyway. So let's take a look at this example and see if we can't figure out together what the difference between doing a simple, an SRS, a stratified random sample, and a cluster sample might be. Okay, so the example talks about a school assembly. Student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about the use of the school library. They'd like to announce the results of the survey at the end of the assembly. Student council president asks your statistics class to help carry out the survey. So there are 800 students present at the assembly. And a map of the auditorium is shown below. Note that the students are seated by grade level and that the seats are numbered from 1 to 800. So we have 800 seats in the auditorium. 9th graders are in the back where they should be, 601 to 800. 10th graders are 401 to 600, 11th graders 201 to 400, and 12th graders, seniors, you guys are up front. Okay? Excuse me. You're more important, right? So you guys sit up front. I apologize for the couple of juniors we have in the class. Anyway, so they're sitting all across, right? So you seniors, you go all across the front row, all across the second row, all across the third row, so on and so forth, until the first 200 seats are filled. And then you keep moving back and back and back. Okay? Now, we want to describe how you would use the following sampling methods to select 80 students to complete a survey. Okay? Well, piece of cake, right? SRS first. We've talked about this. Should not be a major problem here. See if I can't get it done pretty quickly. So to do a simple random sample, we're going to label students. We're going to do it 001 to 800, right? And so we're going to take the first 80 unique. Unique takes care of the repeat problem, right? 80 unique labels from 001 to 800 as the sample of students. Okay, and you might need to find some more room to write that out if you want to write this out. Okay? So that's a simple random sample, pretty straightforward, no problem. We probably would want to talk about starting at line 101. Okay, I scrunched it in there, but it should be included in there. Now, to do a stratified random sample, because we know that library use for freshmen might be different than seniors, because you seniors have figured out that a library can actually help you in your studying. Freshmen probably haven't figured that out yet. We want to make sure that not all of our sample comes from one grade level, which is certainly possible if we're just going to do an SRS. So if we're going to do, if we're concerned about that, then we can do a stratified random sample. Now the nice thing is you guys are already broken up into grade level. So what we could do is, again, we're going to label all students again. I'm going to abbreviate this. Label students, and it's going to be the same label as before. So bring this label down. Okay. Oh, sorry, it can't be the same way. Let me back up here. Label students. Now, there's 200 in each grade level, so 0, 0, 1 to 200 in each grade level. Okay. Now, for each grade level, we start at, and I'll erase this and write out the cluster sample in a second. We start at line whatever, okay, 110, doesn't matter. And take the first, now we need 80, so from each grade level we're going to want 20, right? So we're going to take the first 20 unique, and we need to include, unique 3-digit labels. I didn't do this in the first one, shame on me. 3-digit labels from 001 to 200. And then I'm going to come down here and combine these 20 from each grade level as my sample. Of 80 students. And that probably actually is a little bit more vague than it should be, but that's pretty much it. Okay, so that's your stratus. Now I'm going to take 20 from each grade level and get a good healthy mix of all of the opinions, if I think they're going to be different by grade level. Okay. Now, clusters. So now I know that talking to the individual 80 students might be kind of tough. So what I'm going to do now is I want a cluster, and I want the clusters to look like the population. I want it to be a good mix of freshmen, sophomores, juniors, and seniors. If you take a look, all of the seniors are across here, all the juniors are behind you guys, all the sophomores are behind them, and all the freshmen are sitting back here. So if I just go down a column here, then I'm going to have a good mix of students, right? I'll have seniors, juniors, sophomores, freshmen. So I could use these guys, these columns, as clusters. Okay? So what I can do as a cluster sample is I could label each column from 01 to 20. I only need two-digit labels now because I only have 20 columns going all the way across. Now starting at line whatever, I'll leave that blank. Take the first and see how many clusters do we need. How many? Well, we're going from here all the way back. We're going to have what? Basically 40 rows, right? We're going to have 40 rows. Okay. There's 20 across. To get to 800, we need 40 rows, right? So I'm going to take the first two unique two-digit labels from 01 to 20 and combine these two clusters to make my sample of 80 students. Okay? So this way, all I have to do is pull 2 entire columns, ask them, give them the survey about library use, and it might be a little bit easier to get the information that I need. So that's an example of a simple random sample, the stratified random sample, and the cluster sample. Okay? Make sure we keep straight the stratified random sample and the cluster sample, and the differences between the two, right? And the advantages and disadvantages of each. Okay? Now, that takes us to the check your understanding on page 219, which talks about being at a basketball game. And so what I can do is we can end the notes now. I'll let you work on that check your understanding, write out your responses there. And when we get to class tomorrow, we'll pull some of your responses and put them on the Elmo and see what we think about some of the answers to those questions. Okay? So work on that. Do finish up your homework that was assigned in class, and you'll have more homework to take a look at tomorrow in class. Okay?